Everything we did yesterday and on the homework. What was given to you? Every single proof we did yesterday. What was always given? Bro, what was always given? It was something was a parallelogram, wasn't it? Something was a parallelogram. Today, now you got to prove to me it's a parallelogram. Okay, now you got to prove to me this quadrilateral is a parallelogram. And I don't want to read these off to you and say this is the way, this is the way. I want to show you visually what the heck I'm talking about. So just take a quick look. Nothing's in your packet. There's really 5 ways you can show me a figure's a parallelogram. 5. Okay? So this is what you want to do to your diagram for the proofs we're going to do today. First option you have is you could prove this. Can you prove this exists? What is this, by the way? Opposite sides, parallel. If you can do that, it's a parallelogram. Maybe you can't do that. Maybe it's impossible. But maybe you can do this. What did I prove there? Opposite sides, congruent. So if you can do that, that's a parallelogram. You don't need to do both, but as long as you can do one or the other, it's a parallelogram. Here's what else you could do. What's being proved there? Opposite angles congruent. Now, take a look. Not good enough. That's not a parallelogram. Everyone good? Not a parallelogram. You need both pair. And I haven't seen a proof in a while that uses that method. So it's there, though, if you need it. What else could you do to make a parallelogram? What's that? If you can show the diagonals bisect each other, it's a parallelogram. What am I really doing here? I'm just showing what? What are these? From yesterday. What am I just showing? Isn't this one of the properties exists? That's it. Show a property exists. And then there's a special case. All right, here's a special case that ends up being a parallelogram. One pair congruent. And that same pair, if you can prove them parallel, it's a parallelogram. So that's what I call the special case. All right, if you can show me one pair and the same pair is both congruent and parallel, you got yourself a parallelogram. Before I jump into the proofs, let's do a little just basic practicing right now. I'm going to give you information. You guys let me know if that's good enough for a parallelogram or not, and why. Right off the bat, number 1, SPX, angle SPX and TMX are congruent. Stop. I want to see if you have it in you. If you know those 2 angles are equal, what else do you know now? Come on, dig deep. If you know those 2 angles are equal, what else is true? Mahmoud, come on. Darn right, that's why you belong here. SP has to be parallel to MT because what type of angles are these? Alternate interior, darn right. Let's keep going. What else did I give you? TPX. TPX is congruent to SMX. If those angles are equal, what else is true? Go further. Jonah. SM is parallel to PT. There we go. Because those are alternate interior. So if I give you those pairs of angles congruent, is that a parallelogram? Is that one of the pictures I had up there? Is that a parallelogram? Darn right it is. Yes? What would I write in my reasons column I want to talk about now? So I got that all done. I said it's a parallelogram. What's going to go in my reasons? Remember yesterday we started out with parallelogram implies the property. If you want to prove it's a parallelogram, flip it. What property am I using up here? 24, what property am I using?
Opposite sides parallel.
So that's what I'm going to start with right now. Opposite sides parallel means it's a parallelogram. And I got to put parallel on there. All right, so we got opposite sides parallel. All right, now it'll go a little bit quicker here. All right, is this enough information? SX, XT are congruent. SM, PT. Does that make a parallelogram? Having one pair of sides congruent and one diagonal being bisected. Is that good enough? Absolutely not. Good. Absolutely not. That's a big no spot. Next up. Let's see, what do I have here? PX and MX, SX and TX. Good enough? Parallelogram? Yes. What property are you showing here? What's the property being shown? 18?
Diagonals bisect each other.
Yep, so diagonals bisect each other. Implies a parallelogram. And then we got one more. See if this makes a parallelogram or not. SP, MT. SP and MT are also parallel. Is this going to make a parallelogram? How about this diagram? Parallelogram? Yeah, this was our special case. All right, but unfortunately, I'm not going to allow you to write special case implies a parallelogram. You do that, some of you will be special cases. All right? So this is a yes. What am I showing? I know we say special case because that's just a shorthand of talking to each other, but what am I showing here? Paul, go ahead. Try it out.
Opposite sides parallel.
No. You said opposite sides. I don't have both pair. I only have one pair.
Oh, one pair.
There we go. Hold on. One pair. Go ahead. Keep talking.
One pair of opposite sides parallel and congruent.
Perfect.
Sides, parallel.
Yep. One pair. Notice how, again, everyone good on Paul's mistake there? Can't say opposite sides because that's not true. I only got one. One pair of opposite sides, congruent and parallel, implies a parallelogram. Okay, there's our special case. All right, you're going to go in your groups right now. Take a look. You got eight possible parallelograms. For time's sake, just tell me yes or no. No reasons. For time's sake, just tell me yes or no, no reasons. Go ahead, discuss it in your group. Should take you about a minute or two.
7 yes. No.
But if I call on you, make sure you know why.
9 is no.
I don't need you to write it down, but make sure you know why.
8 no, because you only have one side, so it shows the Wait, you mean yes, no, no, yes. Like it's not telling you that it's parallel. No. Yeah. Yeah. We don't talk about that.
10 yes. 11 yes.
Yeah, 11 yes.
12 yes.
12 no.
12 yes.
Oh yeah.
And both pairs.
No. 13 yes. 14 no.
Ready? Let's do this. If it's a yes, make sure you tell me why. 17, parallelogram?
Yes, diagonals bisect.
Darn right. Great job. Next one. 16, parallelogram. Nope, not enough info, right? I need the other pair parallel. I need the other pair congruent or this same pair parallel. Moving. 16, I already heard. I'm going to hear for 8 different people. Oh, maybe not. 15, next one. Garbage. 4. No. I got a lot of information, but not enough. Not the ones I needed. 1. Number 10.
Yes.
Yes. Why?
Both pairs of sides are congruent.
Opposite. Got to have the word opposite in there, everyone. Opposite sides congruent. How about 11? 17? Nope, already heard from you. Get out of here. 21.
Yes.
Yes. Whoa. That's a yes? I just see a couple little mini angles there congruent. Where'd you get that? You're correct. I'm just busting your chops here, but how'd you get there?
The alternate interior angles are
Which means what now? Thank you. Opposite sides parallel here. Perfect. Number 12. Got enough info? 3? Nope. Need both pair congruent, not one pair. Hey, question 13, 14. Is that good enough? Yes. Why? Yep. There's our special case. One pair parallel and congruent. And then finally, how about 14? 23? Nope. Need both pair. All right, we good. What makes a parallelogram and what won't? So you ready to hop into a proof now? Maybe not, but we're going to anyway. Woo! Stop writing, stop. Look at the first given. PQRS is a, does it have any special properties then that we've talked about? No. A lot of people see quadrilateral and think, oh, opposite sides congruent, opposite sides parallel. No, it's got 4 sides. There's your property. That's it. That doesn't mean anything. All it's telling us is, hey, PQRS is 4 sides. I got 1 congruent to 2. I got 3 congruent to 4. All right. What do you got for me now? If 2 and 1 are equal, that means something, I think. And if 3 and 4 are equal, I think that means something as well. What else is true now? If I look at those givens, what else is true? Whoa. 14? All that suspense for nothing. No 14, right?
No.
Yes? Oh, sorry, Quan. Sorry for the disrespect.
Yes. Parallel to
Yep. PS, that's because 1's congruent to 2. And anybody have anything else? Because 3 is congruent to 4. I'm just going to put it in the same statement. It'll be the same reason. 13?
Not here.
Ah! 19. If 3 is congruent to 4, what else?
PQ is congruent or is parallel to XR.
There we go. You guys remember this reason? What's up, Lauren?
Alternate interior angles congruent for implies parallel lines.
Just like riding a bike, just got to get back on and go. Alternate interior angles congruent imply parallel lines. Yeah. Do I have to go further, or is this a parallelogram? Is this a parallelogram? Yeah. PQRS. And I just want to ask, how do we know it's a parallelogram? 21, how do I know this is a parallelogram? Yep. Opposite sides parallel implies parallelogram. Good work, everybody. Don't go on to the next one yet, though. I just want to talk. Could you, because maybe you don't see the alternate interior angles, could you have proven the triangle's congruent? Is that possible in this proof? Could I prove the triangle's congruent? Is it possible? Yeah, after you say QS is reflexive, right? And then you could have said CPCTC and proved it a different way. Okay, so there's other ways to do it. Hi, Caitlin.
Could you have done like addition and added 1 and 4 and 2 and 3?
You could, but remember, you need both pair. So I would also need 4 and I need P and R to be equal. Okay, which you could have, because if you prove the triangle's congruent, CP/CTC would have said P and R are equal, and then you could have had that. Yeah. All good? All right, another one to end it. I only got 2 here today for you. Oh boy. I wish they were all easy as example 1. How about this one, everyone? Given a parallelogram, prove one inside's a parallelogram. Oh boy. All right, so I got AE and CF congruent. They gave me that for a reason. Right there. Everyone see where the parallelogram is? It's the big dog, the original one here. Oh boy. Do you guys see the one we're trying to prove a parallelogram? Everyone sees it? Okay, here's what I want you to do in your group right now. Try to get a pair of sides congruent. In that parallelogram, we're EBFD. EBFD. Can you figure out how to get a pair of sides congruent? Go ahead.
You can prove the triangle is congruent to Does that make sense? Okay.
Do something quicker. Do something quicker. You are right, Avery. You are right. I just don't want you to go down that path.
What is it?
DC and AB are congruent. So you just subtract AB minus EB equals, or AB minus
So couldn't you just write that?
Hey, let me be more specific. Use your given to get another pair of sides congruent. Try and avoid proving the triangles congruent. You can. I just want to try to avoid it.
Parallel. No. Opposite sides congruent, and then you just subtract. So A minus AE is equals to CD minus CF. Subtraction. Yeah.
All right. How you guys getting a pair of sides? Talk to me. How you getting a pair of sides on this one? 11. How you getting a pair of sides?
I said it was AB is congruent to DC.
Hold on. I want to go slow here. AB congruent to DC. Everyone agree in that? That those two are equal. Why are they equal, Paul?
Parallelogram opposite sides congruent.
I'm using one of my properties from yesterday. Since ABCD is a parallelogram, its opposite sides are congruent. Yes. And then what am I doing with those sides and the sides I was given? Subtracting them. Correct. That's how I get a pair right away. So I have AB minus AE is the same as taking DC and subtracting FC. And that would make DF congruent to EB. Substitution. Here's where I want you to start. Don't just start writing down random stuff. Here's where I want you to think. What else would I need now to make this a parallelogram? You already have DF equal to EB. There's 2 things that could happen that would make it a parallelogram. 2 things left. What's one? One thing. Eva, what's one thing I could do? The same pair I just work with, get them parallel. And I'd have my special case. Get them parallel. Or, what else could I do? And it would still be a parallelogram based on the work I just did. Jonah?
Prove DE is congruent to FE.
Prove the other pair congruent as well. DE congruent to EB. DE congruent to FB. Sorry. Are we okay there? Both can happen, by the way. Both are possible. I'm going to force you to do one way so I can introduce a new theorem. This can happen by proving the triangle's congruent and saying CP/CTC. I heard a lot of you say that. It was awesome. Okay, so you can prove the other pair congruent by proving the triangles and then CP/CTC. All good? I don't want to do that, though. I want to try to get the same pair parallel. That's what I want to do with you right now. How can I get DF and EB to be also parallel? Do a little magic trick here. What do you know about those two line segments? They're parallel. Answer this question, please. Are those two little pieces parallel? Are they? Yeah. Are those pieces parallel? Yeah, they are. Why am I going over this with you? Don't even shut down. It's all fired up, ready to reveal everything. The grand finale, and it shuts down. Karma, maybe? I don't know. Yeah, sure. Get him back. Get him back. Get him back. And I don't even have those line segments in here. Maybe? Okay. So we were all good that the originals were parallel, so the little pieces should be equal. All good? Why am I telling you this? I don't even know where I am anymore. Why am I telling you this? Go back to your diagram. Guys, what do we know about DC and AB? Yes, they're congruent, but they're also what? Parallel. So shouldn't the pieces DF and EB also be parallel? Yes. And that's the new theorem I'm going to show you right now. First, though, you got to tell me the originals were parallel. What were the original ones? AB and AB parallel to DC. The originals were parallel because it's a parallelogram, and that implies opposite sides parallel. So now I'm just going to say, hey, if they're parallel, so are the little pieces I need. But I'm not going to say little pieces in my reason. What are the little pieces that are now parallel that I'm concerned about? DF parallel to EB. And here's what you can say now. And this is one of the two theorems we're going to use. If the smaller parts are parallel, parts of parallel lines are parallel. Parts of parallel lines are parallel. So if you want to say the smaller segments, that's what I'm going to use. And do I have a parallelogram now? Yeah, special case. Special case. EBFD. And again, if you want to use that little symbol I talked about yesterday, that's fine, but it's only for a parallelogram. And just going to need one of you guys to finish this off. What's that reason why it's a parallelogram now? 9. Why is this a parallelogram? Good job.
One pair of opposite sides, parallel and congruent.
Good. It's a mouthful. It'll take some getting used to. Good job. Anything you want to ask before we officially write down this theorem? Anything? All right. So we just learned this one, right? The new theorem, which is parts of parallel lines are parallel. What if I want to go backwards, though? Like the pieces are parallel, but I need the full ones parallel. right? The pieces are parallel, but I want to get the full side parallel to each other. Instead of using the word parts, we'll use the word extensions. Extensions of parallel lines are parallel. So that's if I need the full segment parallel. All right, turn that page. Work with your group. Work with your group. Get after it. Turn that page and get after it with your group. Just like it was classwork. Get after it. Go, go. Get after it with your group. While they're here. While they're here.